Alrighty, here we are on the 3.12 day one note. So technically this is day one because the day two page says day two on it. Properties of inequalities. So, usually, you know, we haven't really done this with the dice ever in person, so don't feel like you're missing out on a lot. But we do kind of just go along and fill in the tables and we look at the patterns, okay? So, where it says preserves the inequality symbol, that means it stays the same. Okay, that's what the word preserves means. Now, if it reverses the inequality symbol, that means it changes. It changes or it flips. Okay, so we're just going to do a few examples here in each one of these stations, all right, and just look at the patterns and then see if things were preserved or reversed. All right, so if you look here in station one, we've got -3 is less than 5. Oh, first, before we even get into this, let's put the symbols at the top to help us remember. Okay. So remember we read from left to right. So this guy would be less than. This would be greater than. And then this would be less than or equal to. And this guy would be greater than or equal to. So I know you've probably learned all of these before. You've probably talked about alligators or Pac-Man. Whatever helps you to remember, you use it. Okay? So we have -3 is less than 5, and then we added 2 to both of the numbers, and we still ended up with -1 is less than 7. So that's the inequality was preserved. So maybe now we're going to do, even simpler. Just 2 is greater than 1. Okay, and we're going to add -3 to both sides. So we're doing 2 plus -3 is greater than 1 plus -3. So 2 plus -3 would be -1. And then is that greater than -2? Yes, it is. So again, this would be preserved. Okay. If I did a little bit bigger numbers, maybe I said 10 was less than 20. And I was subtracting 2 from both sides. So 10 minus 2 is less than 20 minus 2. And 8 is less than 18. All right, so again, this was preserved. Okay, so that's the first table. It says examine the results and make a statement about what you notice. So I think when we look at this, we notice that when you add or subtract the same number to both sides, so when I'm just going to put plus slash minus the same number, the sign is preserved. Okay, and then you can go ahead and flip the page. So we got a different table here. So now we have first -3 is less than 4, and we were multiplying by -1, and you can see here that that made us change the signs. All right, so maybe I had, again, simple, like 2 is greater than 1, and now I'm going to multiply both of these by -1. So 2 times -1 is -2. 1 times -1 is -1, and now I would have to flip my sign to make it a true statement. -1 is bigger than -2. It's closer to 0. So again, my sign would have to be reversed. All right, if I go a little bigger, maybe I have 10 is less than, no, it was not a good less than sign. 10 is less than 15. So I'm taking my 10, multiplying by -1, and 15 multiplied by -1. So I have -10 and I have -15. My -10 is greater than now, so I would have to reverse the sign. Now, what if I had two negative numbers? Let's see, we got to check and make sure it works too. So if I had -5 is greater than -4, So multiply both by -1. So I would end up with +5 and +4. Oh, I had my sign reversed. Jeez, Miss Paul. Glad I caught it. -4 is bigger than -5. But now when I multiply by -1, they become positives. My 5 is bigger than my 4, so again, it would have to be reversed. Okay, so when you look at the table, you'll notice we multiplied by a negative both times. Okay, so when we look at it, you would say when you multiply by a negative, the sign is reversed. Okay, and then go ahead and flip the page. All right, we've got a few more stations to go here. All right, so number 3 here. Station 3, I'm multiplying by, let's see, I got a fraction first, so let's go down to the whole number. So let's say we have 3 is less than 4. I'm multiplying both of these by 2. So 3 times 2, is that less than 4 times 2? Well, 6 is still less than 8, so this is preserved. Now what if I divide by 2? So maybe I have 10 is greater than 8. So I'd be doing 10 divided by 2. Is that greater than 8 divided by 2? And 5 is still greater than 4, so again, it would be preserved. Okay. Now let's skip that next one. Let's go down to the bottom and let's try with some negative numbers now. So if I have like -3 is less than -2, and I want to multiply both of these by 3. So -3 times 3 would be -9. -3 times, +3. -2 times +3 would be -6. Well, -9 is still smaller than -6, so it's preserved. So now when I'm looking at my patterns, I multiplied and divide by a positive, my sign is preserved. So when you multiply / divide by a positive, sign is preserved. Okay, and then flip the page. One more table here. Hopefully by now we can think about, what we think is going to happen. So if I have 10 is less than 12, and I want to multiply these by -3, so 10 times -3, is that less than 12 times -3? 10 times -3 is -30. 12 times -3 is -36. And no, that's not true anymore. -30, oh boy, is bigger than -36. So my sign is reversed. Now what if I check one? We're just going to do one more here. Let's keep my 10 and 12. 10 is less than 12. And now what if I divide by -2? So 10 divided by -2 is less than 12 divided by -2. 10 divided by -2 is -5. 12 divided by -2 is -6. And now I'd have to reverse my sign again. So our conclusion is when you multiply, I guess technically we did multiply. Multiply or divide by a negative, the sign is reversed. Okay? So really the big theme of this is, if I have 2 less than 5, an operation that preserves the inequality would be like adding 2. okay? So 2 plus 2 is still less than 5 plus 2. 4 is still less than 7. Now, an operation that reverses the symbol would be like multiplying by -2 or dividing by -2. Okay? So if, maybe I'll change it to 1. Let's change it to -1. Right? 2 times -1 and 5 times -1. 2 times -1 is -2. 5 times -1 is -5. So this would cause me to reverse the symbol. So really the theme of all of this, hopefully you kind of saw it through your own little exploration, is that when you multiply or divide by a negative, the inequality symbol gets flipped. Okay, adding, subtracting, multiplying by a positive, dividing by a positive doesn't do anything to it. It's just when that sign changes. Okay, so that's all we'll do for the notes, and we'll do some more practice together in the classroom.